Hey everybody, purpose of this video is to get you some solutions to the binomial quiz involving alarm clocks. So you, 3 questions on the quiz. You've got, what if you have 2 clocks? What's the chance that you wake up? And the same thing for 3 clocks. And then the last one is, you want the chance that you wake up to be 99%, at least 99%, so greater than or equal to 99%. How many clocks? So the first 2 are fairly straightforward. You wake up if at least one of the clocks works. And they've got 50% likelihood of working, which is pretty crappy, but it doesn't really matter. You can put in any percentage you want for the situation. So if you think about the possibilities of if you have 2 clocks, they might both work. This one might not work, this one might, or vice versa. This one might work, this one might not. Or worst case scenario, this one doesn't and this one doesn't. So there's 4 possibilities for that. In 3 of those possibilities, you're going to wake up. Right? The only possibility where you don't wake up is if this one works and this one doesn't work. But what's the chance of that? Well, this one doesn't work half the time, and this one doesn't work half the time. That means they both independently happen 1/4 of the time. So this one and this one 1/4 of the time. And the reason that makes it nice is you can do it as a complement. It's 1 minus 1/2 squared. This is kind of a fusion of the binomial distribution plus your project. Of course you could use dist fill on this, absolutely, but it's actually easier, I think, to do it this way. So it's 1 minus 1/4, or it's 3/4, or 75% chance that you're going to wake up. So obviously it's better than having 1 clock because you just got 25% more probability. How about 3 clocks? Now 3 clocks gets a little more interesting. You got 3 clocks, which means you got an exponentially higher number of possibilities. But in all those possibilities, like here's one of them, they all 3 could work. Work, work, work. Well, you'll clearly wake up if that happens. How about work, work, not work? Well, one of them worked, so you're going to be okay. How about not work, not worked, works? Again, that's fine. The only possibility that the only arrangement you're not going to wake up for is if this one doesn't work and this one doesn't work and this one doesn't work. What's the chance of that happening? Well, looking at the pattern from the first one, it's a half times a half times a half. So that's the chance you're not going to wake up. So the chance you are going to wake up is just this. 1 minus 1/2 cubed, which is 1 minus 1/8, which is 7/8. And that just jumped up to about 88%, 87.5% if I do my math in my head correctly. So again, you're picking up more probability there. So it's fun. But suppose that's not high enough. Suppose you really want it to be 99%. You want to have enough alarm clocks to get to 99%. So there's a couple ways you can do this. You can say, all right, if I know 2 alarm clocks gets me 75%, 3 alarm clocks gets me 88%. How many alarm clocks do I need to get to 99? Well, you can solve that equation. You know, there's one way of doing it. Let's do this in color. One way of doing it is to do 1 minus 1/2 to the n equals 0.99. And you can solve that equation any way you want to. You can graph left-hand side, right-hand side, and look, this is going to be an exponential, and wait till that approaches 0.99. That's one way of doing it. You can also solve it manually. You can bring this guy to this side, bring this guy to this side. You're going to have 0.01, which is 1%, 1/2 to the n. Now what this means is, there's a 1% chance they're all going to fail. So all n of them are going to fail. Now that one, again, you could graph that one if you wanted to as well. This becomes an exponential decay model, going down like that. And this is a bottom line for which it's eventually going to hit. If you want to solve it manually, and again, please realize you don't have to solve these manually. You can do this via technology. If you've taken any kind of pre-calc course, there's a wonderful thing called a logarithm that undoes both sides, or undoes that variable. You take logs of both sides. It's going to be n natural log of 1/2. And then bring this guy over to this side. It's linear now. 0.01 ln 0.01 over the natural log of a half. And that equals n. And that, if I did the math correct earlier, I was actually working on this problem before I talked to you guys, I think that's about 6.6 or 6.4 or something like that. But the idea is you can't have 0.6 of an alarm clock, so you have to round up to 7. This is kind of like the pumpkin seed problem from your second project, so you probably got a relationship there to it. So there's one way of doing it. It's totally fine. Another way of doing it is continuing the pattern you had above tabularly. And I think a lot of students seem to like doing it this way. If they don't like the equation approach, they just say, well, we know that with 2 clocks, so we're going to let x equal the number of clocks. And this is going to be the probability that x clocks, I have a hard time spelling C-L-O-C-K-S, wakes you up. So you can just create the pattern, 2, 3, 4, 5, 6, 7, 8, 9, so forth. And look for the function in here. This is 1 minus 1/2 squared. This is 1 minus 1/2 cubed, and you can see the pattern. This guy becomes the variable there. 1 minus 1/2 to the 4th, and so forth and so on. 1 minus 1/2 to the 5th, dot, 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 dot. And just keep continuing the pattern until you get one of those expressions to be below, above 0.99. And then you've gotten it. So, I mean, any way that you want to attack that. I like this way because it's direct. I like that way because you get to kind of see the pattern working. So, just my personal preference, and actually I just gave you 2 personal preferences. Regardless, I hope it helped, and we'll see you in class.